Fine, we start, so we keep the timing, because there is speakers after us, right? We are, my colleague Jon and I, we are from RISE, Research Institute in Sweden. And we are focusing on data centers, all the way from the ground to the cloud. I'm the site manager, lab manager, and Jon is our scientific leader. And our plan is I will introduce our work a little bit, RISE and our data center RISE. And then Jon will talk about things that are relevant for this summit. So he will talk about some of our projects and some of our studies we have done on open compute gear, etc. So I will start then with our research facility, tell you a little bit about our overall our activities. So we are on a mission to help the industry in the data center space, regional, national, Nordics, Europe. We have projects now all over Europe, really. So from the beginning, it was maybe more Swedish oriented, but it's much bigger now. And we are there to increase competence in the area of data centers and try to attract more research, more scientific research into the area, so to increase the knowledge in the space. And we want to be the leading European research institute in data centers. Our work is centered a lot around our test and experimental facility. We want to put our hands on real equipment, not just simulations and theory. Of course, theory and simulations is an important part of what we do, but we want to build and try it out. So a research facility is part of our work, and these last 2.5 years we have built. We are renting a space in an old storage facility, and we have there 600 square meters of data center research equipment. We have a number of modules, we have a lot of servers, we have a lot of power and cooling equipment, etc., etc. And the idea is that since we have knowledge and competence in all the areas from the facility side all the way up to AI and big data computation, knowledge in that space as well, we offer all this as a service to companies, to projects, to university, other academia institutions. So we have a mix of different type of projects. We have one H2020 EU project and many other Eureka projects, and we have Swedish finance, and we have direct finance projects. You can read about this, what we offer on this website, ice.6.se. It talks about all the different things we can offer and help you with. We have, as on the right-hand side, for example, we have GPU clusters that you can run using a Hadoop as a service. It's a software virtualized big data analytics platform. And then we have a compute cloud based on OpenStack. And then we have a number of modules. The first module we built is really our core data center. There we run this as a regular data center, and we monitor it. Very important for us is to do a lot of monitoring, collect data about the operations to try to understand how it works. So this one is regular commodity Dell servers, a little bit on the high end maybe. And here is where we have our GPU cluster and GPU servers, etc. And we also have integrated one rack of open compute equipment into that and run it in this experimental cloud. Module 2, was the second one we built, and it's more oriented towards facility experiments. So we can exchange equipment here. We have raised floor here, so we can do raised floor experiments. We have the quick connectors, so we can exchange the PDUs and racks and cooling equipment, etc. And here we have done a lot of experiments on cooling, really. As most of the experiments in this module has been in the cooling area. We are currently doing one bigger experiment there. And then same here, we do a lot of data collection. So in each of these modules we have 30,000, at least 30,000 measurement points, and currently we are probably at 10 gigabytes per day per module. So we are collecting a lot of data that we can use for analysis and also for learning, which we are setting out to do. We have one project we will start in November 1st. With many partners, we're going for autonomous data center. Module 3 is our Open Compute Lab. So there we have OCP equipment. We have currently we are setting up with windmill servers, but we also will run Winterfeld later servers there in our later experiments. So that's our module 3 that we will try to make it into an Open Compute Lab. And then a surrounding area in this facility is our experimental area, where we have a lot of different setups. One thing we have there is our microgrid. So we have an own little microgrid with solar panels on the roof. We have our cooling grid, where we can store cooling liquid. We also have a module from Box Module. It's a 2-rack little module that could be seen as an edge data center. So that experimental area, we can do a lot of different experiments. We have 2 types of wind tunnels, one for racks. It's a top right picture there, wind tunnel for racks, and then the middle one picture is a wind tunnel for servers. So we can study servers, the performance of servers, and find sweet spots for the servers, etc. And on the bottom side there, we have a little experiment on liquid cooling. So it's a bathtub kind of setup that we are trying to. We have PhD students working on this and trying to learn about liquid cooling. So that is our experimental area. Jon, your turn. You can later on ask questions about if you want to know more.
Hopefully you can hear me okay. Yes. So I'm going to introduce this project that's funded by Horizon 2020 to look at a prototype data center in the north of Sweden. So, and just in case you didn't know where we were, there's let's see if I can get the mouse over onto the screen there. You can see the red dot here is where Luleå is, actually where Boden is, which is a little bit further north than Luleå. And you can see down in the picture, down in the bottom here, the site area where we're going to build the data center. So we're actually opposite a co-location data center, which is well known in the region. So the project has a very provocative title, to build the most cost and energy efficient data center, well, sub 1 megawatt prototype data center in the world. And I wasn't there when we came up with that title, so whenever I talk about this, we can be shot down in flames. But if you ever remember the Carlsberg advert, I will put the word probably in there as well. Probably the most and cost-effective data center in the world. So what's the project about? What's happening in Europe? There's been some research done by Bertoldi, who looks after he's at the JRC, he looks after the participation and the reporting on the EU Code of Conduct. And he wrote a paper back in 2013 talking about the size of the European data center market. So obviously it's consuming energy. And whenever we're prototyping a data center to be energy efficient, we need to have some kind of comprehensive monitoring and measurement tool. So a lot of this presentation will focus on the measurement and monitoring tool that Tor mentioned earlier on, that has been developed at RISE, and that's based on open source. So we're talking about open compute hardware that we'll be using in this data center, using open source software to monitor it. Now, some other aspects of it is to focus on reducing power losses. So we're not going to use a UPS. We're going to try and run a data center without UPS. Again, that may be interesting. Reducing the cooling power consumption by doing some interesting collaboration between the IT and the facility cooling cooling solution, and obviously to try and get better utilization of the IT by deploying some kind of workload. So the workloads will be synthetic and real. I'll mention that a bit later in the. So the project started in October last year, 2017. Here are some pictures of the site and the building in construction. And of course, whenever you do any of these projects, so RISE itself, we're not actually building the data center. Our partners in this project, based in Hungary, in Budapest, who have expertise in building data centers, are actually building this. And whenever you do this, you should always have a time-lapse photography of the build. Now let me get the mouse back here and see if I can start this. And this is a very interesting, you can see the size of it. It's quite a small data center. It's going to be nominally a 500 kilowatt data center. It's, we did look at trying to construct it either using containers or steel and concrete. But in the end, we went for wood because of requirements locally on the heritage. Again, the color of the building is also restricted by the local heritage. And I believe our neighbor data center has a similar color. Andy's smiling there. So I've got to remember, how do I get to the next one without playing the video again? Right, so a little bit of the footprint inside here. So there are 3 pods, 3 data center pods. The one at the bottom here is what we're calling pod 1 throughout this, is the one that we're going to populate with legacy open compute hardware. And we're going to set it up with a cooling solution that uses direct air, so the air from outside. And the design, if you look at the pitch in the roof, the idea of the design is that because of the extremes in temperature, so the area has seen temperatures down to -30 and up to around about +28 this year, some challenging differences in temperature. In the winter, we will probably recirculate almost the majority of the heat, so we will have to recirculate the heat to keep the air on temperature to the servers at an appropriate temperature. And obviously, if you do that, your humidity will drop, so we have to use some wet pads in that to humidify the air when it comes in. And then obviously in the summer, if we are having difficulty getting rid of the heat, obviously the air will just pass straight through the data center, then we may humidify the air in order to to get down to the wet bulb temperature. The other 2 pods are interesting. So the agreement that we have with the project is that we will have a 500 kilowatt footprint. And what we're offering in those 2 pods are a small footprint for donors to bring their equipment to the data center and to occupy those other 2 pods. And we will, as the project cannot make money, it will just pass on the costs. So if you do know anybody who is interested in having a well-monitored data center that may fall over because it's got no UPS, but we could put some UPS in there if the requirements are such. But want a test facility for some new equipment, then this would be good, because not only is it going to be inexpensive to operate, because cost efficiency is not just the capex, it's the opex in this case. It's also because of the electricity costs up there. But also we're going to be using a monitoring system that is built on open source, so it could offer some interesting propositions. And this is the monitoring system. So it's based on some open source software, which I will go through the chain of open source tools. But effectively, we've got building fans in the roof, because we will use those building fans to eject the hot air. Or also and also there'll be recirculating fans in the cooling units, which are from one of our partners, which is a UK-based company called Echo Cooling. We will connect to those using a combination of Modbus, and also we're talking to obviously the energy and power meters. We've developed some sensor strips which on the ASHRAE guidelines, three temperature points on a strip that has a magnetic back which allows us to connect to the racks and monitor both humidity and temperature. That is networked, so obviously we can pick up that through a combination of, again, SNMP or Modbus to the outside weather station and a couple of other things. And of course the servers, we will be using a combination of IPMI version 2 there to talk to the OCP servers, which are Windmill version 2. And all of this is being streamed into some open source software called Zabbix. And then Zabbix actually talks a lot of these protocols, so we can collect data. One of the unfortunate things about Zabbix is that when you've got a lot of data that's being collected, the databases swell very rapidly. So what we're going to do then is we're going to stream it out of that database in a chain of open source software that allows us to keep the data for long-term storage and analysis. So Tor mentioned that we might want to do some big data analytics on the data, make the data available through some kind of open sourcing, an open research data pilot that we are committed to do in the project. But equally, we are going to put workload on the data center. Now, that's interesting. We don't actually have any customers, but how do you put a workload on a data center when you don't have customers? So there's a whole tranche of research that we're doing with our partners at Fraunhofer to build up the workloads. And the workloads that we're going to be looking at is a combination of synthetic and workloads from the Internet of Things, so sensor data, because Fraunhofer has some speciality in that area of smart cities, predictive maintenance, etc. So I will talk a bit briefly about the data collection. But before I do that, going back to Module 1 and Module 2, we're currently using this data collection system in our current facilities in both Module 1 and Module 2. And we're now wrapping this up, ready to be shipped to Boden, which is 30 kilometers from Luleå, where it will be used on the Boden type data center. But what we have is we have a lot of IT equipment being monitored and the facility, so we can check the cooling power that's going into the modules. So you've got the water loops here. So we're using facility. We're in a cold storage facility, so we have compressor-based chilled water loops, which we tap into through heat exchanger. So although we don't actually have control of the final heat rejection, we do have control of the temperature to the pods because we're on a loop, a separate loop from the cooling loop. So the analytics side of this, kinds of things that you might use are things like Spark or MATLAB or Hive or Julia and the hops which Tor mentioned. So we would definitely need operational metrics like PUE, so we want to read this live from the data center, and we do that at the moment. So, and other metrics we might want to look at. So when PUE is not an efficiency metric, if we wanted to look at IT efficiency as part of, or data center efficiency, which includes the IT, then we may look at some of the proxies that have come out of the green grid. We could try that because we're monitoring data traffic, we're monitoring what the IT systems are doing. So we've got information from the whole stack, as it were. And of course, then there's some continuous monitoring for fault identification and root cause analysis. We want to be able to get the servers and the cooling solution for the facility to have some kind of unified approach to cooling that finds the sweet spot of the data center. When I say the data center, I mean the facility and the IT, not just the building itself, which is an innovation in itself if we can get that to work. And I'll explain a little bit how we do that in a minute. And then there's also experimental evidence and verification. And at the end of this presentation, I will show you a live demo of some software that we've developed that could help us analyze the airflows, because this is an solely airflow data center. So Zabbix, deals with different protocols. So SNMP, IPMI, Modbus, MBus, where we can read directly from all of the components. It's not so easy to use it for post analysis, so it's hard to export. You can do some in the web browser. You can do some certain monitoring. You get some graphical capability, and you can see sort of what's happened in the last 12 hours or whatever. And it's not so easy to do efficient searches. So Zabbix is the collection point, but as I mentioned, we want to push this out for long-term storage. Now, one of the things that has occurred, what's happened at RISE in the sense of development, is that we've come up with a way of being able to store that data with some sensible metadata. So, how is the data stored, and so that we can read this from a long-term storage perspective. So there's a lot of work in actually getting out the information out of Zabbix into these two types of long-term storage. CariusDB is actually a time series database, and it's good for long-term storage and doing some analytics with. But you can see there that how we break down the data into the data center, the pod, the rack, the host, the source, the unit. The ID, it could be, the unit could be, or the source could be, a CPU or RAM or a temperature. The unit may be the units that's responsible for the metric, centigrade, or if we're measuring airflow, for example. The ID, sometimes you have more than one CPU. You always have more than one CPU these days. So you might want to identify that. And there's some optional keys, which we don't very rarely use, but they're there just in case. But to then, of course, there's the Hadoop HDFS, which is divided into hourly files in date, and these are plain text files, and they are readable in JSON format. I think there's browsing the directory in the Hadoop cluster, browsing the directory again. And then this is a JSON format, so it has the timestamp, it has the necessary metrics that identify the actual metric that you're picking up. So this one is probably temperature at 33 centigrade, and it tells us the host, the data center, the rack, etc. In terms of the CariusDB, so again, it has a web interface. We can do search and plots and export from that, and I think you can export in different formats. So if you wanted to do some post-analysis in MATLAB or Excel or whatever, it's possible to get the data out in that format. So again, this is how the raw format from the CariusDB would look like, and would allow us to actually do some high-level metrics from that, or detailed analysis of the data. Now, the thing that's important in order to do this is to get from Zabbix into these long-term storage. Is we need some kind of component that allows us to plug these together. And what we've been using is some open source, another piece of open source software called Kafka. So this is a distributed streaming platform. So it allows us to reliably get data between systems and applications. For example, we've got long-term database storages, or we've got other applications plugging into that. Something that we would like to develop, and I will show you this at the end in the demo, is how we might be able to use this to do some validation from some simulations, which could be quite interesting. So this will write to the Hadoop file system or to the Carius DB as streaming outputs. Or if we're working with collaborators, which might be doing some work in one of our modules, we can stream specific data to a virtual machine for that customer, as it were. So they just see the data sets that's appropriate for their application. And of course, this is straight from Zabbix. This is the kind of graphical output you get. I just picked up a very quick change of things here. So this is from pod 2 when we had some maintenance work. So the cooling loop, so the black curve there. Let me see if I can get the cursor over there. This black line here is the water flow. So we turn the water flow off here into the data center because we're going to do some maintenance. We still had some systems on, so the temperatures was rising, so that the flow and the return, obviously, as the data center gets warm, the flow and the return got to the same temperature. So it just gives you an example of the kind of output. So that's sort of the monitoring system that we will develop in this Horizon, that we will use in this Horizon 2020 project to monitor this data center in Boden, which is made up of using OCP hardware, and we'll be monitoring it using this chain of open source software. But what I did say to you was that we were trying to innovate on the cooling side, where the monitoring system will also be helpful. And that is, this is pod 1, which I talked about, where we have the OCP hardware. Now what we'd like to do is, well, I can't get the mouse back on there. But what we'd like to do is we specify the supply temperature from the cooling units. So the cooling units are bringing outside air into the data center. If that air is lower than the supply temperature we want, we will mix some of the hot air return to get to the target temperature. Then what we want to do is we want to specify a return temperature. Okay? Now, to specify a return temperature, we are actually saying we want a delta T across all the hardware of X. So we want to dial in a delta T across the hardware. Most people work on set points of temperature or pressure set points. In this case, what we're going to try and do is try and specify a delta T across the IT, irrespective of what the workload of the IT is. Because the IT, obviously, as it does more work, it will get hotter, and therefore its flow rate will increase. So that, but the delta T may not be the delta T that we're asking for. And to do that with this OCP hardware, we've created a small control card, just here. So what you can see there, which basically it's a small card that sits in between where the fans were connected to the motherboard. It interrupts that and through some mechanism through the OCP hardware, we can take control of the fans, and therefore we can then dial in a flow rate that we would want across the server for a target delta T. But obviously you need to know a lot about the server, how it behaves with different workloads, because that generates different temperatures. And so we would need to do a lot of analysis beforehand to try and get a better understanding of that. So I'm going to skip that next slide because in the interest of time. But what you can see here is the black line there, which is pointing there. That's the signal from the motherboard, the OCP motherboard. We don't have access to the BIOS. So maybe in the later versions of the OCP, we could do this through the BIOS of the OCP itself. But what you can see there is the green curve is the signal that we're sending from the small card that's sitting in between the fans and the motherboard. So basically there's 0 watts from the fans and then they're switched on. So we have got control of the fans. Now what we need to do is understand the relationship between workload and delta T for that. And to do that, we use this wind tunnel that Tor mentioned at the beginning of the presentation. This has now got cladding on it, but what you can see there is a long pipe along the bottom there, so that we, from a fan, a radial fan there, which accelerates the air down the pipe to a heat exchanger, HEX at the end there, where with a water loop we can control the temperature. So we can control the inlet temperature. And the reason we have that long pipe is so that we can measure exactly the airflow, the volumetric or the mass flow rate of the air. So we know what the airflow is into the server. We're holding the temperature, and then all of this is connected to our monitoring system to monitor both the temperature across on the server, the beginning and the end. So you can see we've got different temperature sensors down the whole length of the wind tunnel, so to get an aggregated value of the temperature, so that we can get an accurate measure of the delta T across the server. Now, this has been used already for some OCP experiments. So this is basically showing CPU utilization from 10% to 100% of two OCP servers. The windmill servers was two systems side by side. And what you can see is the range of bars here is basically different inlet temperatures. So you can see what the power consumption is, right? This doesn't show delta T, but it shows power consumption at the moment. But it also shows you that as you increase to 0.9 or 0.8, 80% utilization, there is a difference in power consumed by the server between 19 degrees and 30 degree inlet temperature. And that's a combination of power drawn by the fans, because in this case we're not taking control of the fans just yet. This is just an example of using the wind tunnel. But also it could be current leakages as well. There's a bit of both in there. And the kinds of things that you can do, you can monitor the memory. So for different memory bandwidth, so this is a project that we're working with a startup company called Agetic. And what you can see here is, I know it's rotating a bit. You can see the power consumption there, the memory bandwidth here, and the CPU utilization. So what we've been doing is a combination of workloads that have CPU intensive and memory intensive activity. And the blue dots are the measured dots from the experiment with the wind tunnel. And then the orange dot is the model that's been put over that fits that curve. And so we can now read off values from that, or you can actually look at sweet spots of the server. So depending on workloads that are memory intensive or CPU intensive or a combination of both, we can then work out what is the best amount of workload that we give that server in order for its operation. So I talked briefly that we would try and we do some workloads in the Boden type data center. And the workloads that we're going to concentrate on are synthetic and real. And also the real will come from industrial Internet of Things. So now we have our data center with our legacy OCP equipment in it. We've got direct air cooling. We've got a monitoring system which is monitoring every single part of that data center, from the power from the cooling, the temperatures, the pressures, the weather conditions, the environmental conditions, as much as we can possibly get. Also what the servers are doing. So I neglected to say at the very beginning, because we're using obviously open source software like Linux and Kubernetes for workload orchestration, we can direct data from Kubernetes directly into Kafka and collect data from the actual servers and the operating system, as well as all the hardware. So from the software stack and the hardware stack. And so what that would result in is using a series of containers, which we have a workload definition, which we will push the containers onto the data center in some kind of process. We might just do it one server at a time, or we might try and load one server to its sweet spot at a time to see what kind of energy efficiency we can get out of the data center. But the workloads are built up. We use either synthetic workloads to give a background workload, or a combination of these workloads that are defined by IoT. Now, that diagram's quite complex, but what it says is that if I wanted to do smart cities, for example, I'd have a story that I'm trying to, I'd have a list of sensors, I would have databases, I would have actions on those sensors. So what Fraunhofer have tried to do is break down the workload into units, into application primitives and use cases within that. And we have actually built these containers, so Fraunhofer have built these containers, so we can now push those containers onto the data center when it becomes live. I haven't got much time left, but lastly, what I wanted to do is to show you how we might use, in the future, how we might use the data coming from Kafka, which is the element that collects the data from Zabbix and passes it on to long-term storage, for validation of, say, modeling, for example. So here is our module 2. The picture was taken before we reconfigured it, which we constantly do for experiments. And what on the right there is just showing you how the air flows. So it's running as a slab floor at the moment, so we have cooling units which are pushing air directly into the front of the servers, and then that's being returned back to the cooling unit, as you can see there. And what we're going to do is we're going to use this is the simple geometry. So this is the layout of the pod 2. You've got sort of a diagrammatic form here, and then a pseudo diagram, a pseudo configuration, which we're going to use in the simulation. Okay, and the cooling units are at the top there. So the dimensions are on the left of the room and of the cooling units, and on the right they're in a certain dimensions for the simulation. Now the simulation, this is the CAD of the room, and that's actually a picture from the simulation. Now what I was going to do is I was going to connect to Lulio from here over the internet and show you this is running on a GPU. So GPUs, the great thing about GPUs is you can simulate on them, but you can also visualize directly from them as well. So let me see if this works. I still have it connected, right? So to prove that this is live, so this is actually our module 2, and it's currently, you can see what you're seeing there is the temperature. So you can see the hot aisle here, and the heat are coming up here and returning to the cooling units here. It's meshed at the moment, so and I can move these planes up and down. So that's the plane left and right, and this one I can move this into the hot aisle, so I can get a cross section into the hot aisle, right? And I can move this plane down to the bottom, so you see the cold aisle in the bottom, right? But what I can do right now in front of your eyes, so hopefully this works, is I can change the inlet temperature of this cooling unit here to 26 degrees. Now, this is near to real-time simulation. It uses a different kind of technology than what's used in general CFD, but it's a. So now I can hopefully, if I take the cross section up there, you can see that that cooling unit is producing hot air. Now, if I leave this to run for a little while and come back to it in a minute, you will see that because this cooling unit now is maybe malfunctioned in some way and producing warm air rather than cold air, you can see what the ramifications are to the data center. Now, let me see if I can if I bring that cross section there, you can see there's a lot of technology behind this, which I don't have time to go into, but it's running live on a GPU in Lulio, one of our GPUs, and simulating and visualizing at the same time. So what kind of results do we get from the simulation then in terms of comparison to what we measure? So on this slide here is a power profile. On the top there is the power to 2 racks within that 10-rack data center. So it's on one side, it's that one's 18 kilowatts, this one's 4.5 kilowatts, and then it's dropping down. And what you can see is, so the power profile is an input condition. That's an input to the CFD. And what you see below are actually the temperatures that are measured by those sensor strips that I mentioned earlier on, which are connected to the racks at different points. So these are 3 sensors in the back of the rack, and those are the 3 sensors in the front of the rack. And then you can see the red curve is the experiment, the measured one from our monitoring system, from a measuring system, and the blue curve is what the simulation is saying. It's still not perfect, but there is good. It's giving us a ballpark figure. Don't forget, air is very badly behaved usually. It's not like moving liquids in contained pipes. So that simulation is really good. It needs some improvements, which is all technical. But the last thing I wanted to say before I wrap up is that that Kafka streaming, what we can do now is stream the data, the input data, live from the data center into the simulation tool. So it can read rather than running an experiment and then taking a time history of data and then simulating it. We could read it live and then simulate. If we use more GPUs, we can simulate faster than real time and see what happens to the data center in the future. So we will set this problem up for the Boden type data center once it's operational and see whether we get good agreement there. So just to summarize, 10.2. So obviously we're operating and monitoring experimental test data centers in the north. We have a platform which is based on open source software to monitor this on open source software for IT utilization, lab-based, and any lab-based experiments. Our wind tunnel is using the same monitoring tool. We have now created a 150 kilowatt IT footprint using legacy OCP, and then that is going to end up in the prototype data center in Boden. And hopefully we'll be able to characterize the thermal and power in combination with a programmable delta T across those servers. And hopefully the EU-funded project is developing a strategy for deploying synthetic and near to industrial IoT workloads. And the website to follow this, if you wanted to find out more about the project as it evolves and hopefully succeeds in its mission, you can find that in bodentypedc.eu. I think we have a time for a few questions, so thanks for spending a few minutes and listening. We'll take any questions if you have any.
The CFD software
Yeah.
that you were using, you said it looks, it's unfamiliar with it. You developed yourself.
Yes, we developed it ourselves, yeah.
Open source that.
That would be good, wouldn't it? Yes. It's, I mean, it was developed, before I went to RISE, I had a PhD student working on this. It runs, I don't know if you know anything about programming GPUs, but it's NVIDIA GPUs, so it uses CUDA behind, and because it's on a GPU, you can visualize and simulate at the same time. So, with the Kafka, if we can get the Kafka streaming to work, so you get real-time boundary conditions from your data center, then it would be an interesting one to maybe open source. Do you think people would take it up? It's actually difficult to run, difficult to set up.
One idea we have talked about this, maybe start up a OCP project. That could be a proposal on these type of things for the data center, like monitoring and so we open source stuff into that. That type of field within the data center.
So it wasn't funded commercially to develop that. We still got to make improvements to it. So the models need to be improved, and there are systematic ways to do that.
So there is a new PhD student working on it.
Yeah. No other questions then? Rabbi, you must have a question. Yes, you probably didn't. You missed the time-lapse photographer, yeah. But when you borrow my computer, you can, in a minute, you can run that time-lapse photography. Oh,
I'm going there.
yeah, go in there. Yeah, okay.
I was in the beginning.
Yeah, that's it. This is where it is. So that's the location. Andy's familiar with that.
That's
which is
Hydro 66. You
Hydro
didn't
66.
mention you have to make some advertisement.
Yeah. And then this was the thing being built, time-lapse photography. But so yeah, we've got a small data center, which will soon will be operational by the end of this year in terms of IT and cooling and power. And then we've got this open source monitoring system to take data from it. And one of the missions of the project is to open source some of that data as well. And we're collecting data from the software layer, from the IT hardware layer, and from the full data center as well. So all the environmentals, all the power, and the metrics as well. PUE, if you really like. Or we don't like to talk about PUE, maybe. Yes. But of course, it's one of thousands of ways of designing and building a data center, as we know. Which is the problem. There's no blueprint for a data center, is there? Any other questions? Okay, well, thanks very much for listening, and we'll be around, yeah, to talk. Thank you.